By the end of this video, we will have a CRUD Rest API in Kotlin, and we will use different technologies: Spring Boot, Gradle as a package manager, Hibernate as an ORM, object relational mapping, Postgres as a database, a SQL database, Docker, and Docker Compose. So we have many technologies, and in this single slide, you can see a raw architecture of what our application will look like. So, as you can see here, we'll have 4 functionalities. There will be 5 endpoints. In this application, let's say that it's the core of this live stream. You see this is the Spring Boot logo, the Kotlin logo, the Gradle logo, and also the Docker one, because we will Dockerize this application writing a Dockerfile. We will also run a Postgres container and we will link both the applications using a network that will be created under the hood for us, defining services inside a Docker Compose YML file. Here at the bottom, you can see the tool tests that we will use. We'll use a Postman to test the APIs, we'll use Table Plus to test the DB. Maybe we'll also check the tables directly from the command line. It's something that sometimes I like to do. Perfect. Nice. So let me check here. Where is the live stream? This is the live stream. Perfect. Sometimes I'll check the live stream. Perfect. Nice. So, creating an application in Kotlin and Java, it's always a bit tricky. So, we will start creating the project. Before we start the requirements here, I think it's just Docker installed and up and running. You might say, why do I don't need Kotlin? I don't have Kotlin on my machine. Well, because this time I decided. Oh, maybe I have it. I have Kotlin, okay. But we will not run unless we really have to debug it Kotlin on our machine. We will run this directly through Docker. Perfect. So how can we create a project in Kotlin? Let me see. We can do this in different ways. I'll show you something that it's optional, but it's very convenient, which is to use the Java extension pack on VS Code. So you will need these extensions if you want to follow along. And here are, I think, these ones. Java extension. Okay, and you can see them because I am here. Okay, by the way, can you see them here? Like they are, okay, Java extension pack for Java and Spring initializer. Perfect. Nice. So we start from here. And as you can see here, it's a bit hidden, but you can still see it. There is this create Java project. I know it sounds funny because we're creating a Kotlin project, but this is the name of the button. So let's click on the create Java project. One moment. Now, when we click this Create Java project, we will have this prompt here at the top. And we can basically create a Spring Boot application. This is the Spring Boot application. Now we can select the package manager, and we will go with Gradle today. Then the version of Spring Boot that we want to use. I'll use 3.0.5, but any 3.0x should work. The version of the programming language, is Kotlin this time, okay. The initial group ID, I will leave com.example, and as the input artifact ID, which is basically the name of the project, I can leave demo. The packaging type, we can go with jar or war, and the Java version 17. Okay. Now we need to define the dependencies, and we will have, as we had in the Java Spring Boot project, I'll leave a link, but it's in this series, will have 3 dependencies. One is Spring Web. Then we will have JPA. Spring Web is to handle HTTP requests. Then we have JPA, which is to handle persistence in this in our project. And the last, we need the PostgreSQL driver, because we want to connect our application with a Postgres DB, so we need a sort of driver to handle this connection. That's not enough, we have to configure it, but this is a dependency that we need. So we need just these 3 dependencies. Now, if I click select 3 dependencies here, something strange happens. It opens my Explorer here, my files. So I can go on any folder I want and create the project inside that folder. So I already created a folder here because I wanted to come prepared, because I always forget to create a folder. So I go in C workspace, you can go in any folder you want, and I have a specific folder I should have, which is named Kotlin Live. So you can choose any folder you want. So let's go in this one. Generate into this folder, I click, and here at the bottom right there is this open button. You can see the OP. Okay, nice. So we basically, this is our way to create this project. Okay, nice. Now let's start working on this project, because this is basically an empty project. So the first thing that I want to do is to define the connection with the database. Usually I do this at the beginning, because otherwise I forget. Because after I write the Dockerfile, I want to run Docker container. So let's define the application.properties files lines, and we will have, so we need to define the environment variables and a couple of more things. So let's go with spring.dataSource. We are defining the URL of the DB equal, we'll use of course an environment variable because we don't want to hardcode it here. So DB URL. And then we need the username and a password. I don't like this name. I like PG_user and PG_password. Now, a couple of more lines. Spring.jpa.hibernate, which is the ORM, .ddl auto-update. This is to update the schema of the DB when we'll define entities. So this is basically to create automatically some tables. One table will create. And the last line here is basically, I will let the GitHub Copilot handle this for me, and it's basically the dialect, because Hibernate, this ORM, can handle different databases. Postgres is just one of them, but we have to set the dialect, like if Hibernate was talking, to a Postgres DB. Nice. Now, what we can do is to create basically all the logic of the application. So how can we do this? Can you see this like below my face? There is this demo folder, and I want to create another folder at the inside this one. So let's say that I want another folder. Let's say that I want to create users. Okay, so I create a folder called user, and I'll create three different files. So inside this folder called user, we define something called user.kt, which stands for Kotlin. Then we have a file called usercontroller.kt, and then user, I think, repository.kt. Okay, nice. So we have these three empty files. Let's start by populating the user.kt file. Now, since I am in VS Code, I don't have like all the package defined, because usually I should have this. If you're using another IDE, you probably have this by default, but I can do this because I have GitHub Copilot. So package com.example.demo.users. Before I forget, I'll add this also to the other two files, user controller and user repository, otherwise I'm sure that I'll forget. And now we need here to import the Jakarta persistence, and I'll import everything. We don't need anything, but I'm lazy. And here we can define our model on steroids. Why on steroids? Because this will be annotated as an entity. We can define the table that will be created inside the database, and here we will have something kind of basic. So we'll have a users table. It will have an ID, which will be auto-incremented, and then this can be an int. This is the primary key, of course, and then we'll have a name and an email. We don't need a password. Let's remove everything. So this is our class, Kotlin class, already prepared to become a table on the database. Okay. Nice, and this was done. Now let's go on the user repository.kt, and here we can import org.spring-framework, and I think this is data dot repository CRUD repository. There are different CRUD repositories. There is CRUD repositories JPA. I'll go with this one. It's the most straightforward, and we are done basically. So we just need this interface that will allow us to have some methods to basically interact with the DB automatically, and this is cool. Nice. Let me check. Perfect. Nice. Now let's create the user controller. So let's go here in the user controller, and let's import some dependencies here. So we have org spring framework dot beans dot factory dot annotation, and here, because here I want to auto-wire and to handle the dependency injection for the user service, basically repository. Then we can import org.spring-framework, and here we want http.http status. Yes, and now we can also import the response entity, basically to handle the response of the HTTP request. And last but not least, I want to import also this annotation. Okay, perfect. Now we need to create this user controller. This is basically a REST controller. If you are familiar with Spring Boot, probably you are familiar with this one, even if you just use this in Java. So REST controller. Then we have something called request mapping. Request mapping is basically the URL that we want to hit. Like, so when we'll go on localhost 8080/API/users, we will basically handle this set of functionality. So this is like the main URL, and then we'll have some subpaths, of course. So let's create a class. The class is called user controller dot user controller, and then here we can use auto-wired, so to basically have the dependency injection for that user repository. And here, I don't know why, GitHub Copilot never helps. Okay, user repository. Okay, let's close this. Let's handle this. Okay, now we need to get so now here, get all the users. So we need basically to write our endpoints. Okay. And this is probably the hardest part because I'm not familiar with the Kotlin syntax, but let's try. So In Kotlin, we can define a function with the keyword fun, and we will call this get all users, parentheses, here, and then here basically we want to return a list of users, maybe not like that, but we can have here user repository, and you see here we have this functionality, define all, which is basically to get, it's basically a select star from users and having them organized in a list, but this is independent by the model, which is very cool. Now, create a user. So to create a user, we can create, don't like this, let's go with fun, create user, let's have some fun, and here we can use this request body user, but here we want a response entity, so we want to handle the request, okay? User, which is here, this is a generic response entity. Now here let's remove this, okay, and here we have val save the user, so we save the user inside the DB. Also this method, the save method, is a method from the user repository that we didn't write, but we are basically saving the user, creating the user. Now, to get a user, here we need to add a get mapping. So basically to define the routes. So the method is correct, but we want to define this. So get mapping, post mapping. This is basically to handle the HTTP verb on the request. So to get a single ID, we can go with this, and then we can have this, which is fun get user by ID. And basically we have just a path variable, let me copy, but I'm not sure, path variable ID, and then user ID, which is an int, and then we will return as a response entity a single user. So user will find by ID, so for example if we want to user number 3, or else null, and then return. If the user is different to null, we'll return the user, otherwise we will return an HTTP status not found, which basically corresponds ATA, which basically corresponds to 404. Now, we need two more functions, which is one to update an existing user, and this is usually very tricky. So let's see if I can do it. This is usually it always gives some error here, so I want to be sure that I type it correctly, or at least trying it. So path variable ID and then user ID. So for the update, of course, we need everything. We need the path variable, we need the request body. Yes, request body, so user ID int, the request body at request body. Of course, it's of type user. We are using the user as a model. And then we need the response entity. Response entity user. Okay, so now we get the existing user. So we get this. So val existing user equal to user repository find by D. So we want, let's say that we want to update the user number 5. We go on /5. So first of all, it checks that the user number 5 exists, because this is an update. It's not creating a new user. This is why we ask for a path variable. And then if existing user is equal to null, if, let's go like this, existing user is equal to null, so it means that basically we are trying to update a user that does not exist in the database, will return, let's see, will response not found. Otherwise, we could do val update the user, existing user, copy, and we update the existing user, but of course we'll update just the username, and the user email. So just name, and email. Name, email. And then we need to save, basically. Okay. See, we save the user, as you can see, okay, here, status, okay, nice. So, just let me check something here, name, email, perfect. Let's go on the last method, which I think it should be easy, which is the delete the user. So we need this delete mapping, we need to provide an ID, and here, I think it's correct. Let's type it, fun delete user by ID, because we need to define an ID, and then we go on path variable. Path variable is basically the parameter that we pass in the URL. I like this part, but not want to be sure that I want the rest. ID, which is user ID. So basically, we get this in input as an ID, and we put this into a variable called user ID, just to use something else just for this method. And then this is of course a response entity, response entity. User. Okay, so this is the type of response. Not sure if you need the user as a response, but okay. So if because we deleted it. Oh, so user repository. So we try to see if this does exist. So if we are trying to delete something that doesn't exist, we return an error. It's correct, but because let's say that we want to delete the user number 3, but it doesn't exist. We need to throw an error. And then here, user repository dot delete by ID, user ID, and then we can return should be status no content. I think that we could remove this, but let's keep it as it is. Nice. So we made the user control. It was a bit challenging for me, but it's okay. Now let's go on the Docker part, which is probably the most interesting for this project. Nice. Hi everyone, remember to leave a like. I'll show this video. Let's go. Oh, 60% of the people, they tried Kotlin. Cool. I don't know, this is the first time on a live stream. Oh no, I made another poll. Okay. Nice. Perfect. So Dockerization. Let's create 2 files here. Dockerfile and Docker compose.yml. Sometimes I like to create like files in bundles. Okay, so as I said, this part will be a bit interesting because we want to build something, especially a jar file, Java-like file inside the Docker image. So as a base image, we can use different stuff, but I saw that the OpenSDK has been kind of deprecated, at least the version 17 that I was using. So we use something called Amazon Corretto, which sounds like Corretto coffee, I don't know. We need to define here, we create a directory, workdir, usually I use /app. Then we copy everything, copy dot. You are copying from this folder, from the folder where the Docker file is located, to inside the Docker image file system. Then we build the project inside the container. Gradle clean build -x test. we are skipping the test and for when we build this. The reason is that while we build, this app is not connected to a DB. It's this is running another container, so we don't want, otherwise this will have a crash because it says that it has not the connection. Then we need to expose a port. It works even if we remove this line. This is more for humans. Run the app. So to run the app, as you can see here, we have this Java jar, and this is not this one. We need the basically, which is demo. Okay, so we probably will not have a target and jar file inside our Francesco's computer, because this jar file will be inside the Docker image, which is still on my computer, but not on this Windows file system, we can say. Nice. Now, let's go on the Docker Compose file, and I'll let you know soon which is the part which I think is the most interesting for this live stream. So, a Docker Compose file is basically a file to define services, to define multiple containers, and also the process of building the images. So we go on the services. So usually I made this different many times. So usually we will have just two services here. Services are basically containers. So the service is called Kotlin app, and as a container name, usually I use the same name as a service, even if it's not mandatory. Then we can define any image. The image can be anything, but I like to create something xx slash Kotlin app latest, okay? And then we can define the build. And now, usually in many tutorials that you see, also my tutorials, usually at build you put a dot. It means build in this directory. Here we do something a bit different. Here we want to define a context, which is basically the path. So basically, this is exactly as saying build dot. But if we do build and we want to define different stuff, we can have this context, which is basically the path. Then Dockerfile. Many times I say that you don't have to call the Dockerfile with capital D. And this is true, because depending on the project, maybe you have a different on multiple Docker files. So we want to find, I don't know, this Kotlin Dockerfile. Here you can define your custom name for the Dockerfile. This might be, Kotlin Dockerfile, but I have to call this file Kotlin Dockerfile. But this is not the point of this. Here, the different things is that here I want to define what I call args. What are args? Can you read here? Arguments used during the image build process. This is exactly what I need. Args, not env, because env are environment variables that I use once the app is created. But here I want to build the image based on some stuff. So, can you remember the three environment variables that we defined in the application.properties file? DB URL, PG user, and PG password. Okay, these three lines, they are connected to these three. Sometimes I make some typos. So DB URL, PG user, PG password. This is application.properties. If I go on Docker Compose, I have here, I'm defining the environment variables at build time. Nice. Now the ports, build ports. These are the ports of the, and I like 8080, it's okay. And now we need to define also the environment variable. And this is very tricky. Why do I have to define the environment variables if I already have the arg? The reason is that here in the Docker Compose, I also want to define the environment variables with their real value. So let's remove this, and this. So as a DB URL, we'll have, let's do like this, not like, okay, here, Oh my god. Okay, so as a DB URL, we go with JDBC PostgreSQL DB. Okay, this is very important. So we have this is the port of the service, this is the database, and this is the name of the service, which can also be the IP if we are not using Docker. Postgres user, don't use this in production, of course. Depends on the service DB that we are just about to define. So, DB. The DB service, we already see this multiple times. We have, this is basically the Postgres container. So I'll go fast here. And here we have a container name, the image, which is Postgres 12. Maybe we can use a later version, but I'm sure that the 12 it should work, or at least that if we have an error, it's not the Postgres version. The port 5432, the environment variables of the Postgres container, and I think we just need the volumes. Volumes are a way to have persistency in the containers. And I think that it's like this. Okay, but these are like the volumes defined by the service. I also have to create the volume. Okay, nice. So we should be done with the code. Okay, and now, but it's not. I don't think it's done yet because I always have some error when I do this. So nice. So let's run our container. So Docker compose app-d, which stands for detached db. So we want to run this service. Bam. We have a warning, but it's okay. Nice. Let me just check. Docker ps-a. Okay. And now the hardest part. Docker compose build. This will build all the images that are defined in this Docker compose file. This might fail hard. Let's see. Build failed. I never got it at the first try. So in the user controller KT, unresolved reference beans. Why? User controller. It's not data. It's just beans. So it should be like this. But to be sure, let's see if I do this. Okay, so okay. Second try. Build failed. Let's try again. Let's see. Gradle. Okay. Okay. Okay, I got it. User controller, line 40. 14. It was wrong like this. Let's try again. I don't have done, so we should be okay now. Now we need to run this. So just a couple of, usually it's like 5 times. So Docker compose app, Kotlin app. This is the name of the. By the way, what do you think about the new layout? Docker compose app, Kotlin app. Kotlin app. Kotlin app. Bam. Running stuff. Spring. Does it crash? Let's see. It worked. It worked. So we didn't have any error. So the first thing, nice. Now, let's test it and then we are done. Docker compose app -d. So usually Docker ps-a. ps-a, sorry. Okay, so usually when it does work, the first thing that I check is, okay, the containers are up and running, and here the ports are okay. Usually the problem is that if you didn't define a port, like here, so this is the port exposed, 8080, created a status up. So to test it, we can use this different ways. But one way can be this one, get. But before we do any request, let me show you something, if this is correct. Let's go here, on Table Plus, we refresh. And as you can see here, now we have a users table. Who did that? Why do we have this table? Because we didn't make any request. If we step inside the Postgres container again, and we go on /dt, we see this. Now, remember before it was empty. Public users table Postgres. And if we select star from users, it's empty. Okay, so we have this table. This has been possible before because we had the application.properties file with this update in the Hibernate one, and also because this user was not a normal class, but it was an entity with a table annotation. So this created the users table inside the DB. Nice. Let's go with the test. Get localhost API users. And here we have an empty array. Now, to create a user, we can do a post request at /API/users with anybody we want. It can be AAA mail. Here you can drop your name, so I'll create a user with your name, send. And we have this user. And as you can see, the ID has been added automatically by the system. So I don't define the ID when I create a new user, of course. Let's see. So we'll create 3 users. We are basically done. So, mail. Okay. So we can create a BBB. Okay. Create this, a BB email, and then also CCC. Perfect. Nice. So we created three users. If we get all the users again, now we have the 3 users. Can you see them? 1, 2, 3. Okay. To get a single user, you can go do /API/users, and as a path variable as URL, you put 2 here, and we have a single user. You see, this is an object. To update, we don't need this. Okay. When we do a put request, instead, let's say that we want to change this with my name, Francesco, here, also in the email. Oh my god, what happened? Okay, it's okay. Let's, okay, it has been updated. Now we get the user, number 2, and to delete, we can also delete a user. We don't need the body in this case, of course. Let's delete a user here. Let's delete the user number 1. Click. We don't get an answer, but as you can see here in the check, there is a 204, which means that it has been processed successfully. So we don't go back with an answer, but still it's good. And last test, we can get all the users again. We have user 2 and user 3. Done.